Transformer author's new model sparks debate. Essential AI, the startup founded by Transformer paper co-authors Ashish Vaswani and Nikki Parmar, has released RNJ-1, an 8 billion parameter model that has drawn significant attention and some skepticism from the open-source AI community. The model, named as an homage to mathematician Ramanujan and pronounced Range 1, positions itself as optimized for code and agentic tasks, boasting performance that competes with larger models on benchmarks like SWE Bench Verified, where it scores 20.8% in Bash-only mode, outperforming Gemini 2.0 Flash and Qwen 2.5 Coder 32B Instruct under the same framework. Architecturally, RNJ-1 diverges from Google's Gemma 3 in several notable ways. While Gemma 3 employs a hybrid sliding window attention pattern, 5 layers of sliding window attention followed by one global attention layer, to achieve memory-efficient 128K context windows, RNJ-1 opts for global attention in every layer. This simplification trades memory efficiency for complete context awareness at a more modest 32K token limit. RNJ-1 also uses single rope, rotary position embedding, with yarn extension rather than Gemma 3's dual rope system, and substitutes GLU activation with GGLU, a gated variant that may contribute to its strong performance on code tasks. The community response has been mixed, with the 32K context window emerging as a significant point of contention. "I just don't really think any model these days can afford to top out at 32K and compete," wrote one commenter, noting that even with a buffer for replies, complex agentic workflows requiring code rewrites quickly exhaust the available context. Others defended the trade-off, suggesting RNJ-1 could serve as a controlled diff machine in stepwise editing workflows with external memory management. The model's training used the Muon optimizer across 8.4 trillion tokens, and Essential AI deliberately limited post-training to encourage community extension and specialization, a decision that may explain why some users found it quite mid for general use while acknowledging its research value. StepGame reveals AI social reasoning styles. A substantial update to the StepGame social reasoning benchmark has added 12 frontier models, revealing fascinating differences in how AI systems approach strategic deception and cooperation. The game pits 3 players in a race where each secretly selects 1, 3, or 5 steps per turn, but if 2 or more players pick the same number, nobody moves. This creates a rich environment for testing strategic reasoning under uncertainty, bluffing, and real-time opponent modeling. GPT 5.1 medium reasoning topped the leaderboard with a score of 5.3, followed by Gemini 3 Pro Preview at 5.0. The benchmark revealed stark differences in communication style. GPT 5.1 demonstrated calculated aggression with statements like, "I'm willing to burn them to deny you the win," while Gemini 3 Pro Preview exhibited sophisticated emotional gameplay, calling out opponents with P2, "You are hallucinating. Look at the scoreboard." Claude Opus 4.5 without reasoning enabled produced memorable drama. P3 has picked 5 in all 5 rounds. That's not a pattern anymore. It's a religion. Perhaps most entertaining was Grok 4.1 Fast without reasoning, which scored a lowly 1.8 while delivering maximally hostile messages. "Your stall begging is pathetic. You're at 9, a corpse, and watch me win while you rot." Its reasoning-enabled counterpart improved to 3.8 but maintained intensity, at one point declaring, "Block P3's 5 or perish. I dominate." The benchmark demonstrates that social reasoning remains a challenging frontier where raw hostility correlates poorly with success, and the ability to model opponents while adapting to shifting incentives matters more than aggressive posturing. Cold start mystery. When GPUs won't load fast. A debugging adventure comparing A100 and H100 GPU clusters for model loading has sparked technical debate about where the real bottleneck lies. The original poster reported dramatic performance differences when loading models across multiple GPUs. Single GPU loads showed roughly comparable performance, 1.7 GB per sec on A100 versus on H100, but parallel loads across 4 GPUs collapsed to 0.2 GB per second on A100, while the H100 achieved 2.2 GB per second, a roughly 10x difference. The initial hypothesis blamed PCIe Gen 4 versus Gen 5 bandwidth constraints, but the community pushed back hard. You're doing something horrendously wrong, either in your hardware configuration or your software stack, wrote one commenter, noting that even the single GPU numbers were far below expected NVMe performance. A single Gen 4 lane can achieve 2 GB/s, and properly configured systems should hit 10 GB/s or more. The fact that both systems performed poorly on single GPU loads suggested the problem preceded any parallel scaling issues. Alternative explanations emerged: CPU performance, NUMA topology, NVMe controller behavior at higher queue depths, motherboard configuration, and even RAM caching between test runs. One commenter shared that switching CPUs while keeping the exact same NVMe drive improved single-threaded read speed by 3x, demonstrating how CPU and memory subsystems can dominate storage performance. The original poster acknowledged that multiple variables differed between systems and committed to systematic isolation testing. The lesson for anyone building inference rigs: raw flops and GPU specs matter, but the entire I/O path, from NVMe controller through CPU root complex to GPU memory, determines real-world cold start times. Small model beats giants on hard math. A new approach to mathematical reasoning called PaCoR, parallel coordinated reasoning, has enabled an 8B parameter model to outperform GPT-5 on the HMMT25 mathematical competition benchmark. Released by StepFun AI with MIT licensing, PaCoR represents the first fully open-source deep think system, providing training data, model weights, and inference code. The key innovation is parallel thinking during test-time scaling. Rather than modifying the model architecture, PaCoR implements an inference pipeline that enables automatic parallel exploration and compression of reasoning paths. The approach builds on Qwen 3.8b base, but uses an internally post-trained variant called RLVR8B0926 as a stronger starting point. Crucially, the parallel thinking capability requires both the specialized training and the inference framework. Out-of-the-box reasoning models lack this capability, and the training proves essential for hard, diverse answer domains like programming. Community members noted the substantial token consumption, potentially approaching 1.8 million tokens for complex problems, but parallel processing means this doesn't translate directly to wall clock time for single-user scenarios. The inference pipeline documentation has been updated since initial release, addressing early concerns about reproducibility. While impressive on mathematical benchmarks, the approach highlights a broader trend. Smaller models with sophisticated test time computation can compete with much larger models on specific domains, challenging the assumption that raw parameter count determines capability. Intel's math agent trades verbosity for code. Intel AI Software Group has released Deep Math, a lightweight math reasoning agent built on the small agents framework that takes a distinctive approach. Instead of verbose chain-of-thought traces, the model emits Python code for intermediate calculations, executes them in a secure sandbox, and folds results back into reasoning. This reduces output lengths by up to 66%, while often improving accuracy. The system uses GRPO, Group Relative Policy Optimization, training to encourage this behavior, with a reward structure that gives +1 for correct answers and +1 for generating code snippets, weighted 10-to-1 toward accuracy. Training employed linear temperature scheduling from 1.2 to 0.7 to balance exploration with stability. The team modified TRL's VLLM client and server to generate GRPO completions using the Deep Math agent, enabling the model to learn from its own tool-augmented reasoning during training. Benchmarking across GSM-8K, AIM 2024, Math 500, and other datasets showed that both GRPO training and agentic inference contribute to performance. Ablation studies confirmed neither alone achieves the combined benefit. Interestingly, unlike general coding and math tasks, test time scaling through longer reasoning and parallel sampling proved unnecessary for vulnerability detection tasks. The sandbox execution provides both safety and determinism. Offloading arithmetic to Python eliminates numerical errors that plague pure language model reasoning, while strict execution limits prevent runaway computation. Cupcake, governing Claude code with policy. As Claude Code ships powerful autonomous capabilities, a new open-source project called Cupcake addresses governance through policy enforcement using OPA, Open Policy Agent, and Rego. The project emerged from a feature request for hooks in Claude code, which now provide intervention points where external policy logic can evaluate and potentially block agent actions. The architecture binds a policy enforcement layer with the agent runtime, enabling organizations to define rules, preventing actions like reading secrets or deleting home directories. Using a decoupled policy language allows alignment requirements to evolve independently of the agent implementation. Interactive examples demonstrate security policies for protecting paths, with the project providing both a policy studio for development and enterprise-focused capabilities. The creator notes that using OPA Rego for policy enforcement is strategic, with enterprise applications in mind. Similar concerns about agent governance surfaced in a Black Hat EU keynote, arguing that AI-powered threats extend beyond external adversaries to internal systemic risks. Enterprise systems carrying decades of technical debt weren't built for autonomous agents, and the speaker argued that the defender's real edge is knowing what good looks like. Using AI to model enterprise behavior deeply enough to catch deviations from either attackers or runaway automation. The emphasis on non-functional requirements like digital twins, process visibility, and architectures that degrade safely under attack suggests security models must assume compromise and contain blast radius rather than prevent all incidents. Section brings emotional speech generation. Jipu AI has open-sourced GLM-TTS, a text-to-speech system using multi-reward reinforcement learning to achieve controllable, emotion-expressive zero-shot synthesis. The system employs a two-stage architecture. A llama-based LLM generates speech token sequences from text, then a flow matching model converts these to MEL spectrograms before a vocoder produces audio waveforms. What distinguishes GLM-TTS from traditional TTS systems is its reinforcement learning framework addressing flat emotional expression. Multiple reward functions evaluate generated speech across dimensions, including similarity, character error rate, emotion, and even laughter detection. The GRPO algorithm optimizes the LLM's generation strategy based on these signals, with fine-grained token-level reward allocation providing precise optimization. Results show CER dropping from 1.3 to 0.89 compared to the base model, while maintaining high similarity scores. The system supports zero-shot voice cloning from just 3 to 10 seconds of reference audio, capturing timbre, accent, emotional tone, and rhythm. A phoneme input mode addresses pronunciation ambiguity for polyphones and rare characters, particularly valuable for Chinese where characters like hun have multiple readings. The latest Vox CPM 1.5 from OpenBMB takes a different approach, using a tokenizer-free end-to-end diffusion autoregressive architecture that directly generates continuous speech representations from text at 44.1 kHz sampling rate. Built on Mini CPM4 and trained on 1.8 million hours of bilingual data, it achieves real-time factor as low as 0.17 on consumer RTX 4090 hardware. Flux.2 arrives with safety first. Black Forest Labs has released Flux.2, a 32 billion parameter rectified flow transformer for text-to-image generation that adds single reference editing and multi-reference editing without fine-tuning. The model can maintain character, object, and style consistency across generations using only reference images, trained with guidance distillation for improved efficiency. The release includes extensive documentation of safety measures, reflecting growing industry awareness of image generation risks. Pre-training data was filtered for NSFW content and known CSAM using partnership with the Internet Watch Foundation. Post-training involved multiple rounds of targeted fine-tuning against both text-to-image and image-to-image attacks. External third-party evaluations using adversarial testing with approximately 2,800 prompts across multiple attack vectors informed additional safety fine-tuning before release. The model includes filters for NSFW and IP-infringing content at both input and output, with the license requiring filters or manual review for deployment. Content provenance features implement pixel layer watermarking and C2PA metadata for identifying AI-generated content. For consumer-grade deployment on hardware like RTX 4090 or 5090, Diffuser's documentation provides guidance on loading 4-bit quantized models with remote text encoders. The model is available under a non-commercial license to support research and development, with commercial licensing available separately. Reasoning models hunt 0 days. A new research paper introduces VulnLLM-R, described as the first specialized reasoning LLM for vulnerability detection. The 7B parameter model outperforms both state-of-the-art static analysis tools and commercial reasoning models like GPT-4 on security vulnerability tasks, demonstrating that specialized small models can exceed general-purpose giants for domain-specific applications. The training methodology addresses unique challenges in creating reasoning models for security. Rather than simply distilling from larger models, the researchers implemented filtering that removes reasoning data with incorrect answers, critical because the base model lacks sufficient security knowledge to learn from flawed reasoning chains. A correction mechanism provides guidance for commonly misclassified CWE types. Feeding this context to teacher models, DeepSeek R1 and QQ32B during data generation. The model was integrated into an agent scaffold combining VulnLLM-R with CodeQL-based context retrieval. Given a large project, the agent retrieves necessary context for each target function before analysis. Deployed on 5 popular repositories, the agent discovered 15 zero-day vulnerabilities, demonstrating practical value beyond benchmark performance. Notably, VulnLLM-R trained on specific CWEs from Python and C++, generalized to unseen CWE types and even Java, a capability not observed in non-reasoning classification models. The researchers conclude this generalization emerges from the reasoning training rather than pre-existing model knowledge. DevTools, Observability, Intel, and Distribution Building. A new open-source project called Curl provides observability and replay capabilities for AI agents, recording complete execution traces, including LLM calls, tool invocations, prompts, and configurations. The system enables deterministic replay at 0 API cost for regression testing, with an agent regression score quantifying behavioral drift between versions. Critically, it auto-detects side effects like emails, writes, and payments, blocking them during replay to prevent unintended consequences. For Intel hardware users, getting a Llama working with NPUs and integrated GPUs remains challenging but possible. Intel's IPEX LLM provides experimental Llama integration, though community experience suggests Intel Arc GPUs outperform current NPU implementations. A Docker Compose configuration shared by community members enables Intel GPU support by passing through /dev/dry and setting appropriate environment variables for level 0 device selection. The OpenTelemetry distribution builder addresses custom collector packaging, building on the official OpenTelemetry collector builder to provide complete distribution management. It generates multi-platform binaries and installation packages, APK, RPM, tart, GZ, automates versioned releases through GitHub Actions, and supports build execution via local Docker, Google Cloud Build, or GitHub Actions. The tool follows a manifest-based configuration approach, simplifying updates while handling complex packaging that has historically made custom collectors challenging to maintain. Python deprecation warnings, silent but deadly. The URLlib3 project's recent release removing APIs deprecated since 2022 has sparked reflection on whether Python's warnings module actually works for library deprecations. Despite 3 years of deprecation warnings in a top 3 PyPI package, actively maintained projects including the Kubernetes client, Fastly client, and Airflow were caught off guard by the removal, forcing a hurried patch release. The core issue: deprecation warning is ignored by default in Python. While this is documented behavior and even appears in official deprecation guidelines, the maintainer concludes that, in its current state, warnings.warn does not work for deprecating APIs, at least for Python libraries. Solutions requiring everyone to run with warnings enabled are acknowledged as unrealistic. The problem is especially acute for library-to-library deprecations where the warning might fire in end-user code that never configured warning visibility. Potential alternatives discussed include creating library-specific warning classes that aren't in the ignored by default list, or adopting more aggressive SEMVer practices with frequent major versions like the cryptography project. Neither is ideal. Custom warnings fragment the ecosystem's approach to deprecation, while rapid major versions create upgrade fatigue. The incident highlights a gap between Python's built-in deprecation infrastructure and the practical needs of library maintainers trying to communicate breaking changes to downstream dependencies. Detecting the Watchers, anti-surveillance glasses. A project called Ban Rays aims to create wearable glasses that detect camera-bearing smart glasses like Meta's Ray-Bans, currently playing the X-Files theme on detection. The developer has explicitly avoided using a camera for detection, reasoning that putting a camera on glasses to detect glasses with cameras doesn't hold much water, conceptually. Two detection methods are under exploration. The first exploits that image sensors act as tiny IR reflectors, projecting IR at various wavelengths while sensing reflections with a photodiode produces different signatures for camera-equipped glasses versus regular eyewear. Initial tests show Meta smart glasses look different from regular glasses, though probably not conclusive alone. The second method targets wireless activity, but proved trickier than expected. BLE advertisements from smart glasses only occur during pairing, power-up, or case removal, not during active recording. The project reflects growing unease about normalizing always-on recording devices worn by passers-by. While hidden cameras have proliferated in public and private spaces, there's a social signal when someone holds up a phone to record. Smart glasses eliminate that signal, creating asymmetric awareness about when recording occurs. Previous projects attempted IR emitters to blind cameras or OU sniffing to identify devices, but address randomization in BLE limits the latter approach's scalability. A reliable, non-camera-based detection method remains elusive. Programming's ancient roots and pendulum swings. A philosophical essay argues that programming has never fundamentally been about code. It's about structuring human intent into executable form, making LLMs simply the latest swing of a pendulum oscillating since before computers existed. The Jacquard loom executed conditional logic in 1804. Medieval brewing recipes contained deterministic algorithms with error handling, and the Antikythera mechanism performed astronomical calculations around 100 BCE. The essay traces a great linguistic amputation from Fortran, eliminating approximately and probably through COBOL, Shakespeare rewritten by accountants, to C, abandoning English pretense entirely. Each iteration negotiated how much humanity to sacrifice for determinism. Now LLMs reverse this, preferring Victorian novel normally verbose natural language over the compressed syntax programmers spent decades mastering. The irony crystallizes in the observation. We simplified language for machines. Now machines demand we use the full language to be understood. But the essay cautions against seeing this as evolution. It's oscillation. Prompts are more verbose, less deterministic, easier to write, harder to debug. Neither approach is better. They represent different points on an eternal trade-off between accessibility and precision. For domains requiring determinism, the author works in financial services, probabilistic compilation remains problematic. The idea of a system that probably transfers the right amount to probably the right account is not charmingly innovative. It's what we in the industry call a federal investigation waiting to happen. AGI realists versus context maximalists. A framework for understanding persistent disagreements in AI discourse distinguishes between model maximalists and context maximalists, groups reading the same papers and benchmarks but operating from incompatible assumptions about what intelligence even is. Model maximalists treat intelligence as a single capacity revealed through scale. If a model improves across tasks, they see convergence toward general intelligence. Performance jumps indicate emergence. Failures simply require more parameters or cleaner architecture. The entire capability landscape fits on one axis. Context maximalists start from a different map entirely. Intelligence isn't one capacity, but a collection of strategies shaped by environment, purpose, constraints, embodiment, and history. A system smart in one domain can be hopeless in another. Benchmark aggregates reveal little. Emergence often reflects metrics catching up with smooth underlying curves. This explains why debates about reasoning, alignment, and AGI timelines feel permanently out of sync. One camp expects unification, a general mind emerging from scale. The other expects fragmentation as systems specialize. They're not arguing about performance, they're arguing about ontology. The practical risk is waging operational bets on unresolved ontologies, chasing technical convergence while adoption realities fracture along context. The no-free lunch theorem lurks in the background. Optimal intelligence cannot be general. Every intelligence has its own game to play.